Good morning. I'm posting all this to all my Algebra 2 students, and I guess I can make this available to anyone who wants to just solidify the ideas and steps of just solving equations. If you can do this, then when we get to something that's more complex, be it absolute value like this one here, or you have to do some distribution first. I want you to be able to feel comfortable with this. So I'm going to go ahead and I'm going to list or go down the list and talk about things that you may or may not see in an Algebra 2 class or an algebra class. I want you to go ahead and solidify those steps to solving equations. So there are some steps that you might have to take care of beforehand, and maybe I'll write up some sort of example for each. I did put an example here for absolute value, but if we're talking about fractions and denominators, maybe you do want to get rid of that first. It's also part of distribution and that idea. But this problem right here talks about distribution. So I can't get to my two-step equation until I distribute this 5, because this says 5 times the quantity of 4 minus k is equal to 10k. Well, I can't start to solve. I can't get to step 1, which is undo that addition or subtraction, and then move on to step 2 until I've taken care of this distribution. So basically all you're going to do is multiply everything inside by 5. So I multiplied this. 5 times 4 is 20, and 5 times minus k is minus 5k, and that equals negative 10k. All right? And so now I've got myself in a situation where I can solve a two-step equation where I'm going to do some addition or subtraction and then do some multiplication or division to undo something. This is an interesting two-step equation. I've got a larger value over here and a smaller k value over here, but if I move that, then I'm doing 3 things. So I'm just going to undo this subtraction here, the subtraction of 5k with adding 5k to both sides. And then I'm going to add 5k here. All right, negative 10k's and positive 5k's are negative 5k. And that's going to be equal to, we'll bring our 20 straight down. And I don't like to have a negative, so I'm going to go ahead and I'm going to undo this multiplication of negative 5 times k. And I'm going to rewrite. I always rewrite. This is probably the 17th video you've seen me rewrite. I'm going to divide by negative 5 and divide by negative 5. And the best part about this is negative 5 divided by negative 5 is just 1. And so I have k left over. And then 20 divided by negative 5 would be negative 4. All right, if you're not so solid on your integers, multiplying and dividing, you should go over that. But that's how you get there. So that's the distribution piece. I don't have an example up here of where we would need need to get rid of a denominator, but it would look something like x minus 1 over 4 is equal to, let's say, 3. All right, that's an example of it. And what we would do here, I don't want to put parentheses around it, the first step it would take would be to get rid of this, because this is a whole quantity being divided by 4. So we would go ahead and undo this division by 4 by multiplying both sides by 4. I guess what I can do is go ahead and solve this. Let me write it out here. And now I'll just go ahead and solve it. There's your original. We have a denominator that we need to get rid of, so we're going to multiply because that gets rid of our division by 4. 4 divided by 4 is just 1, so this quantity on top is right here, and then we multiply 4 times 3 and we get 12. All right, and now we have an equation that we can solve. We can basically solve it just by performing step 1 over here and undoing this subtraction with a little bit of addition. So we're going to add 1 to both sides. And x is going to be equal to 13. All right, so that sounds good. We've gotten ourselves into the place of, we took care of our pre-steps, which is getting ourselves to that 2-step or 1-step equation, things that have to be done beforehand. And now I'm going to get to this last type of problem. There is such a thing as getting rid of something that's being multiplied. You know, this absolute value, our goal is to get this quantity inside absolute value all by itself. So when I get to that, we're going to talk about dividing both sides by 2 so that absolute value symbol is all by itself. But last but certainly not least, I just want to solidify steps. Here I have an equation, a 2-step equation. I don't have anything I need to do beforehand. All I'm going to do now is look for any addition or subtraction, and I have some subtraction here. And so for this, I'm just going to add 13 to both sides. And 17 plus 13 is 30. And bring down my 2x. Rewrite it so I can do some math on top of it. Then I can do my division and show my work. And x equals 15, because 30 divided by 2 is 15. There's what it looks like. I'm sorry I was standing in the way. One of these days I'll figure out an easier way to get you guys to see what I'm doing while I'm doing it. But here we go. There's what it was, if you want to look through it. That's solving 2-step equations. The only other problem you guys on a regular basis tend to not necessarily love would be a variable on the wrong side. So I'm going to put together a problem that you guys had on your quiz, and it was 17 equals 9 minus a. Okay, we don't really like this type of equation. We hate the a being on the right side of our variable being on the right side. We despise it, but that's the way it goes. Sometimes it's going to be there. I want to isolate this, so I'm going to undo the 9 here. Well, it's not being subtracted from a. A is actually being subtracted from 9. So I can't add 9 to both sides, because if I add 9 to both sides, I'm doing the wrong thing. I'm going the wrong way. I'm actually adding 9 more, and then a is going to be subtracted from 18, and that's really going to mess us up. So I look at this 9, and there are a number of ways I could rewrite this to make our heads fit, but I just look at this 9, and there's no operation symbol in front of it. There's no negative in front of it, but I want to show the opposite of 9 underneath it. Why do I want to show the opposite of 9? I want to show the opposite of 9 so that I can get a 0 out when I put them together. So when I put these two things together, I'm going to show the opposite of 9 right here, and I'm going to be able to do some math. When I put 9 and negative 9 together, I get out 0, and that goes away. This operation symbol and the a comes straight down. So it's minus a or negative a. If there's nothing there, it's just negative a. And then 17 minus 9 is 8. Okay, so I have 8 equals negative a. I don't like to have a negative variable, so I'm going to multiply both sides by negative 1. I could divide both sides by negative 1, but that doesn't matter one way or another. I would have rewritten this. You could, because you're intelligent kids, show if negative a equals 8, then positive a equals negative 8. You know that if you show the opposites, that they have to be true. Other than that, I think you guys are good to go. I think I'm going to go over it one last time. There are some pre-steps that I showed you in the video. I didn't show you this absolute value bit because that's another video altogether. Step 1, of course, take care of anything that's being added or subtracted, anything extraneous hanging away from our variable. Do it to both sides, and then undo multiplication or division like this over here, and you're good to go. So there are your steps. If you have to, write it down. Write it down, keep it on a little note card next to your desk, and when you're ready to take a quiz, I'm not against you pulling out the steps, because this isn't giving you answers. It's reminding you how to follow a certain progression. So that's it. I'm going to post this for all you guys, and those of you who want to use it, use it. If not, not.